Well, we're back in the inner zone looking at structures, and what I can see here is some fairly complicated folding which are clearly indicative of ductile deformation, but can you take us a bit further than that?
Okay, well, let's start to build up a picture. First of all, let's just point out that there are some quartz veins and quartz patches here, but we can see that there is a colour change which represents bedding, particularly well displayed across this part of the outcrop. So we can follow that bedding and we can see that it is folded around folds in of that shape. So the first thing we can establish is that there is bedding in these rocks which is folded. And those folds, if we see a fold as a product of ductile deformation, then we ought to ask ourselves whether there is a cleavage associated with them, and there certainly is. Over here we can see an axial planar cleavage.
Yes, that they've been weathered out in a spaced way running down here and here.
It's interesting that you would use the word spaced, because that tells me that there's perhaps something more going on in these rocks than we've been able to see so far. Because I would expect a lithology like this, one that is very rich in phyllosilicate minerals, those platy grains that can easily be oriented and develop a cleavage. And the fact that the cleavage we're seeing axial planar to these folds it has got a spaced nature to it, makes me think that something more complex is going on, and that perhaps the obvious folds that we're seeing here might not be the first deformation that had affected these rocks. And I think the place where we see some evidence for that is further down the outcrop over here. And we can see one of these quartz veins and trace it round a fold of that shape. Now that's very different, both in terms of shape and orientation, from the folds that we've just been seeing. The fold is much tighter for a start. It's almost what we term isoclinal. The angle between the fold limbs is very, very tight indeed.
And the axial planes appear to be parallel to bedding.
The axial planes are parallel to the bedding and the layering in this rock, aren't they? And we can just about see that other cleavage here. And that cleavage is just coming straight across these folds, almost at right angles to their axial planes. It's a later cleavage that cuts right the way across that fold and relates to these other folds that we started off seeing.
From this single outcrop, we've been able to recognise older, flat-lying isoclinal folds and a younger spaced cleavage axial planar to more upright folds.
So we're picking up good evidence for a chronology of structures, for a time sequence to these structures. Clearly, two different episodes of deformation resulting in two different orientations of folds and with different cleavages.
Another vital aid to unravelling structural chronology is the recognition of fold facing.
Right, we've come over to the south side of Loch Leven now to have a look at these quartzites that contain some of the best cross-bedding in Dalradian quartzite I have ever seen. It is superb. We have got the relationship where these cross beds here are curving in, that means they're asymptotic to that bedding surface and are being truncated, they're being cut off against that surface. So as a way up indicator, this is as clear as it could possibly be. These rocks are younging in that direction.
Okay, that's really interesting, because on this side of the outcrop there's a fold. You can see the limb folding round an arch here, and the axial plane is given away by this surface here, and transferring your younging information over to the fold, the limbs of the fold are younging that direction. In other words, we're younging as we go down the axial plane.
That's the critical piece of evidence, isn't it? That having found the axial plane of the fold, the rocks get younger as you go down the axial plane. This is a downward facing fold, and the critical thing is that can only happen when there is more than one episode of folding in the area.